So what we're going to do now is we're going to talk about some of the limitations that the intermediate operation flatMap has when applied in the context of Java parallel streams. And this is a very subtle issue, and I would say most people probably don't understand this issue, so you'll be learning some interesting things if you follow along with what we're going to talk about. So it turns out if you take a look at the source code for the Java flatMap implementation in streams, it forces sequential processing. So if you take a look at flatMap, if you go look at the source code for flatMap, you'll see that internally to a portion of the code implementation, it has this portion that says result.sequential.forEach. And so what it's basically doing there is it's creating a stream called result, and that's the result of applying a mapper function, and it'll run sequentially for inner streams that use flatMap. And I'll explain in a moment with an example what it means to be an inner stream and why flatMap is so problematic there. So this limitation with flatMap makes it essentially useless for Java parallel streams. And again, this is very subtle. Very few people really understand this. You can read this article here at Stack Overflow to learn about it. And I'm going to demonstrate why it's a problem. And then I'm going to show you how to fix the problem because it's got a very simple solution. So here's a little program. We're going to walk through this in more detail here in a minute. And in this program, the outer stream will emit a parallel stream of integer objects going from 1 to outer count. So you can see we have an int stream. We generate values from 1 to outer count. We box them up so they're integers instead of ints. And then we make that run in parallel. And then we have a flatMap operation, which appears to be creating an inner stream that appears to be emitting integer objects from 1 to inner count in parallel. So it looks like we should have the outer stream running in parallel and the inner stream running in parallel. And then, of course, what flatMap is trying to do is it's trying to give you back just a stream of integers, and you can then collect that into a list. So that's where we're going. We want to collect the results into a list of integers. The problem is that even though we designate dot parallel here in this inner stream, the code is actually going to run sequentially. And this is interesting for several reasons. First, it's interesting to know this so you can avoid doing this when you write parallel streams programs in order to make better performance. And number two, it's also interesting to try to figure out how to demonstrate effectively and concisely that this is actually the behavior. And so we're going to take a look at both of those things here in a minute. Okay, so that's the problem. And we're now going to take a look at an example program that will demonstrate this problem, and I'll run it for you to show you why it's a problem. So we're now in my EX35 example in my GitHub repository. Again, I'll put the link out so you can see exactly where to find the source code. And we're going to start out by showing why flatMap doesn't scale in a Java parallel stream. And then in the second part of the video, we'll talk about how we can combine the reduced terminal operation together with something called stream.concat to fix this problem in a very elegant and simple way. So let's go ahead and take a look at the first part of the code. We're just going to look at the flatMap problem here to demonstrate what the problem is, and then we'll talk about how to fix it in the next part of the video. So we indicate how many processors we have available, we parse the arguments, and then we're going to run a test that will test this flatMap program and demonstrate what the problem is. As always, I have a run test helper method here, which runs the garbage collector first to give us a level playing field, and then it's going to go ahead and time the test by showing how long it takes to run, by starting a timer, running the run method of the runnable, stopping the timer, and then storing the results into a hash map. Okay, so let's take a look at test flatMap. That's the method we're going to take a look at first. And this is going to show why flatMap doesn't scale in a Java parallel stream. And it's a pretty simple little program, but it demonstrates a lot of cool things. So what we're doing here is we're going to call a helper method called generate outer stream, and we're going to give it a parameter that's the number of integer objects to emit in parallel. So let's say for sake of argument, it's 5, just to make it simple. So here's generate outer stream. It takes that count, which let's say is 5. It creates a stream of ints going from 1 to the outer count. And then it goes ahead and will box everything into an integer, sets the stream to run in parallel, And then just for diagnostic purposes, we're going to indicate the thread ID for this particular iteration that we're running. So that most likely will be a different thread ID, perhaps for each of the different elements, because it's all running in parallel. And you'll see when we run the test that that is indeed the case. So that's how we generate the outer stream, and that works perfectly fine. We then take that outer stream and we call the flatMap operation, which is this intermediate operation that's going to try to denest the results that come out of the behavior that's passed in. And what's passed in is something called Interstream. So let's go take a look at Interstream. So here's Interstream. And first we set up some local variables to help with this cool diagnostic capability that'll show us conclusively that things are only running serially. Just very cool little trick that I'll show you. So we first store the outer thread ID. That's the ID of the thread that called us. We create an atomic integer called counter. You'll see why we make it an atomic integer, because we want to pass it by reference. And then we create a map of long to atomic integers. So it's an association between long, which is the thread ID of the inner thread, or the inner stream, and an atomic integer. And that's going to keep track of how many times that thread is being used in the inner stream. So then we're going to make ourselves an inner stream, and that's going to go from 1 to inner count, where inner count is passed as a parameter here. We're going to box that up so we have a stream of integers. And then we're going to call dot parallel. Now we think we're turning this into a parallel stream, but in fact, you'll see for flatMap, it won't run in parallel. Well, how do we know it doesn't run in parallel? Well, we're going to call a helper method called check inner stream thread IDs. And we pass the inner count, the atomic integer counter, the thread map, and the outer thread ID. So let's go take a look at check inner stream thread IDs. This is a really cool little method I wrote, and it uses some very interesting Java concurrency techniques. So the first thing we do is we call the thread map. Remember, thread map was passed in from the outer scope. It was passed in from the inner stream method. And we say, thread map, please check to see if there's a value associated with the current thread ID yet. If the answer is yes, then we're going to get back a non-null atomic integer, which is the value associated with that key, where the key is the thread ID that we're running here. Now, if it turns out that this is the first time in, then we're going to get a null in return, and we're going to set the atomic integer to its initial value of 1. So we've now initialized that atomic integer with a value of 1 to indicate that there's one thread that's in the inner stream that's got that thread ID. And then we check to see what we got back from put if absent. And if we got back something that wasn't null, we know that wasn't the first time in. So in that case, we're just going to increment the value by 1. And what we would expect to see is if things are indeed running serially, then the thread ID for the inner stream will always be exactly the same for every element. And therefore, the atomic integer will be incremented each time for every element that we're iterating over. So it'll always be the same atomic integer, and we'll just increment the count by 1. So that's how we're going to know it's running serially. And if the iteration, when incremented by 1, if the atomic integer, when iterated by 1, equals the max iteration, then we're going to print out a diagnostic that says inner thread IDs for outer thread equals the contents of the thread map. And that'll give us an indication as to what the results are. So now we're going to go ahead and run the program. And I'm just going to look at the part here that demonstrates the results that we see for the flatMap test. We'll come back and look at the other one later. So you can see I've got 16 cores. We're entering the flatMap test, and you can see that we had the values, thread IDs for 1, 2, 3, 4, 5. And you can see that they appear sort of in a random order because they're all running in parallel. And you can see that the thread ID for the value 5 is ID 20. The thread ID for value 3 is 1. The thread ID for value 4 is 22. The thread ID for the value 1 is 24. And the thread ID for value 2 is 21. So that's just showing you that all those outer processing is taking place in different threads. Now go take a look at what's happening in the inner threads. And this is in the inner stream. This is absolutely fascinating. Notice, for example, that the thread ID for 1 was 24. Well, look what happens for 24. The same thread was being used for 24 to run the inner stream. There was one element there. Likewise, if you take a look for thread ID 2, there were 2 calls in there, and they were both running on thread ID 21. Likewise, if you take a look for thread ID 1, there were 3 calls that were done in there, all on thread ID 1. And then for thread ID 22, there were 4 calls in the inner stream that were all running on thread ID 22. And then finally, for thread ID 20, there were 5 calls that were all running on thread ID 20. So in other words, there was absolutely no parallelism in the inner stream, although there was parallelism in the outer stream. So this is a way to demonstrate very conclusively that the flatMap operation doesn't run in parallel, even when you ask it to be a parallel stream. And then the results here are what you'd expect. You print out 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So that's basically showing you the results for the running of this for the flatMap test, which demonstrates that flatMap doesn't handle inner streams in parallel. And of course, what we're going to do next is we're going to take a look at how we can fix this problem.